So it's with great pleasure that I'll introduce here now Professor Michael Crawford. Now, Professor Crawford is an internationally renowned researcher on brain development and nutrition, and he's noted for his contributions and breakthroughs in the understanding of brain growth and the evolution of the brain. And he has actually predicted the present rise in mental ill health. Amongst other things, he has founded the Institute of Brain Chemistry and the Mother and Child Foundation, and he's been internationally honoured for his input to science and growth in knowledge, including receiving the Order of the Rising Sun from the Emperor of Japan. So let me hand over now to Professor Crawford, and thank you very much, Professor.
Thank you, Dan. Thank you. Thank you again for inviting me to give this talk this evening. It's a particular pleasure to be here in Bangor and to see the progress the students have made and the award that the student assessment is just very heartening, and one's hardly surprised to see the lovely environment and the lovely people that are here to teach these people. I'm going to talk to you about what I consider to be the greatest crisis that humanity faces. I'm not alone in this. Stephen Hawking has said, in view of the problems of population explosion and limited resources of the planet, that we're going to have to leave the planet by 2117 in 100 years' time. That's what comes from Stephen Hawking. And actually, he's right. We do not have time, and I was heartened to hear some of the progress that was being made in oysters and seafood production this morning, and I'm glad to be able to listen to more that will be coming tomorrow. The point about my talk is that it is the human brain that's at risk at the moment. And the trouble with this is that for the last century or so, the whole focus in terms of nutrition and public health has been on protein. And protein is not the issue so far as the brain is concerned. Brain is made of fat and requires special essential fats for its growth, development, and function. Human milk has the least amount of protein of any large mammal. The least amount of protein of any large mammal, and yet it's rich in the sorts of fats that are needed for brain growth and development. And you can see in this picture what I'm talking about. The priority of human development is the brain. This head case of the child is nearly the same size as the mother's. And that tells you that the development of the brain is early. And indeed, it is prenatal very largely. And if you look at the hand of the child compared to the hand of the mother, you'll see the discrepancy in terms of the priority given by biology in terms of growth. The hand is nowhere near the size of the hand of the mother, but the brain case is. And so the priority in human development is not protein and body growth. It is the brain, and the brain requires special fats. So that is what I'm going to be talking about, and the trouble is that with the present food system has gone wrong, and we're now at threat of the rise of mental ill health. There is a very good example of what protein does for body growth. That animal reaches 1 ton in 4 years of growth, gets all the protein it needs from the simplest food resource, namely grass. Protein is not the issue so far as Homo sapiens is concerned. Yes, just to sideline you a little bit about the importance of the marine environment. This is Mount McKinley in Alaska, and of course as the summer comes the snows melt and they wash their way down to the estuary, and that is where the food web of the marine food web takes off in earnest. And there's our friends enjoying the Frutte del Mare from these kind of estuaries, but it happens to be the south of France, but never mind. So the point about that is that, of course, the washing of the land by these rivers is bringing all the trace elements and the nourishment for the marine food web to start the food web in the estuaries. And a lot of the problems you have today is that the estuaries have been polluted and are dead. But there's another issue, and that is that inland you have iodine deficiency. There are 2 billion people at risk to iodine deficiency today, and they're basically all inland people, lands that have been washed clean of iodine by the rain and snow and waters. I was in Indonesia in the 1990s, and we did some work for WHO on the prevalence of iodine deficiency, and there we had 60% of the school children had goiter, about 1,000 cretins in Indonesia. And this was all due to this washing process, depleting the place of iodine. But there was none in the fishing villages, which is the lesson. That it's not only the fats that are important for the brain, but all these trace elements are also significantly important, and I wanted to make this point. I suggested to the government at the time that kelp farm would be a solution to the problem, because kelp farming can provide dry seaweed which is still full of iodine, and that can be transported. But in Indonesia, the high temperatures and so on, the lack of refrigeration, fresh fish and seafood was not an option so far as the inland people were concerned. And that shows you just some of the extent to which, this is a photograph taken by one of my students in the Sudan, and it shows you something of the horrors of iodine deficiency. And this is by no means an abnormal picture that you take in central Sudan for this reason of iodine deficiency. Now, it's the brain that makes us different from other animals, and the brain is made of fat. Now, I want to tell you something about this particular fat, docosahexaenoic acid, or we call it DHA, which is absolutely vital for signaling membranes. Essential fatty acids, like essential amino acids, you know about essential amino acids are needed for protein. Well, you also need essential fatty acids to build cells, but they build the membranes. They build the membranes. And these membranes are responsible for intracellular organization and cell organization, which makes the thing work. And they're particularly vital so far as the brain is concerned, because the brain is really built with membrane systems. Now, to just explain some biochemistry to you, so don't relax, this is the only biochemistry you're going to get. The basis of these essential fats, which I think I need to communicate to you, is two fatty acids, linoleic acid, which has got 18 carbons, and 2 double bonds, or 2 degrees of polyunsaturated fatty acids, and alpha-linolenic acid, which has got 3 double bonds. Now, let me explain what a double bond means. If you have a saturated fatty acid, it means it's got a chain of carbon atoms, and they all can wiggle in whichever way they want, because they're connected by only one loose single bond. But if you remove 2 hydrogens with an oxygen, then you get a double bond between 2 carbons. And that means that when one carbon moves, the other has to move. Now, what does that do? It introduces order into the molecule. So the disorder produces a clump, and you get hard fats. We used to light our houses in the days before electricity with tallow candles, which were made from beef fat, because it's full of saturated fats. And that's what happens with this clumping business and disorder. And this is quite solid. But you introduce just one double bond, and what you get is a liquid. That's olive oil, which is mainly a monounsaturated fatty acid, and that is a liquid at room temperatures, and this is solid. And that just illustrates the significance on physical chemistry of a single double bond in terms of the properties of the substance. Now, plants have very little requirement for what is called liquidity. They stand away from the brief. But we walk about, so we need a high degree of liquidity. And animals, what animals do is to take the parent fatty acids, essential fatty acids you find in plants, linoleic acid with its 2 double bonds, and make it more unsaturated. So you get 20 carbons with 4 double bonds. Now that's fine, but we need that for a whole bunch of stuff, particularly reproduction. Alpha-linolenic acid, the 18 carbon with 3 double bonds, by contrast, occurs not in the seeds, but in the green part of the plant, in the leaves. All green foods are rich in alpha-linolenic acid. That's the primary source. And so the marine environment doesn't have seeds in it, so it doesn't have much in the way of this linoleic, or what we call omega-6 fatty acids, but it has the photosynthetic system, so it has a lot of these omega-3 fatty acids. And the omega-3 fatty acids go adding more double bonds and more carbons to a thing called docosahexaenoic acid, or the 22 carbon with 6 double bonds. And that, I want you to remember, it is called DHA because it is fundamentally important for the brain. All the signaling that you do when you think, talk, or do anything goes through membranes that are rich in docosahexaenoic acid, or DHA. All the photons that you received when you're seeing things come in through a sea of DHA, which makes the visual system possible. So DHA is going to be extremely rich in the marine environment, but not on the land. And this is the trouble of today. Now, just to share with you how we first discovered the importance of this was that I was interested in working in Africa, why different animals had different sized brains throughout the animal kingdom. So we did a study on the fats of 42 different species, and if you look at the distribution of the fats in the membranes, it's all over the place, everywhere. But when we studied the brain, all that variability vanished. What that means is that the brain is built to a very specific profile. It's not the chemistry of the brain that changes from one species to another, but the extent to which the brain evolved, and that obviously had to be dependent on either the ability of the animal to make stuff or the ability of the animal to get stuff from its food web. So that was really how we first became involved in this story. And I could do a lot of evidence, and I'm not going to, just show you this picture of feeding a mother animal with DHA, with marine fats, as compared to a deficient animal. And you'll see what happens with the brain cells is that they migrate out from the center to form the cortex. And you can see in the slide on this side, the yellow dots of the marine-fed animal forming a beautiful cortex, whereas the deficient animal is pretty negligible. Now, one other thing that I think is terribly important is to understand the basic biology of what we're talking about. And you can understand this from an evolutionary perspective. For the first 2.5 billion years of life, there was very little change. It was prokaryotes, and they had no internal cell structure, and they weren't going anywhere. But as soon as the amount of oxygen came into the environment to make air-breathing animals possible, all 32 phyla come into the fossil record, almost like that. Now, the interesting thing about this is that everybody's attached the reason for the origin of the 32 phyla to the origin of oxygen, which is perfectly correct. But if you don't have oxygen, you can't make these double bonds, because you can't take those 2 hydrogens away with an oxygen and make water. So when you have oxygen, you can make a great galaxy of fatty acids, and you can make membranes with them. And for the first time in the history of animal life, of life on this planet, you find at the what was called the Cambrian Explosion, you find intracellular detail made by these fatty acids who make the membranes. And the Cambrian Explosion depended not only on oxygen first, but it also depended on these lipids that form the membranes that do all the signaling stuff and cell function and putting bits in the right places, nuclear envelopes, mitochondria, reticular endothelial system, all these different organizations of the cell dependent purely on fats. So they were absolutely critical. So that gives you the first hint that these fats are going to be important to us today. There's a picture of mitochondria which just shows you the extent to which these lipids in the intracellular detail are involved in membranes. Now, the dinoflagellate, which lived about 600 million years ago, you can still get these things now. If you analyze them, it's got an eye spot. So how was it seeing? And when we analyze the dinoflagellate, we find it's stuffed full of this DHA. When we analyze the photoreceptor in modern mammals, animals, we find it's also stuffed full of DHA. In fact, the photoreceptor is every single molecule in the membrane has a DHA in it, and some have got two. And that is critical so far as the conversion of a photon into electricity to enable you to see. So in effect, you can trace back the origin of the brain to photoreception, beginning to convert photons into electricity, and then that starts the evolution of the nervous system, which ultimately ends up in the evolution of the brain. I just want to make the point that the green bar is the amount of DHA that's present in cod muscle. Now, most people measure oils, but inside the muscle, you've got all these membranes, and they're made of phospholipids, which are quite different to the oils, which are the sort of things that sit around your waistline. And just look at the amount of DHA that you get in cod muscle. Cod liver oil only has 8% DHA. Cod muscle, phospholipid, has 47% DHA. And this is terribly important as far as oysters are concerned, because oysters are the same. They have 22% in the phospholipid and only about 4% in the oil. Now, really, what I'm telling you is this, that frankly, with the dinoflagellate, the cephalopods, we've measured all these things, the fish, the amphibia, the reptiles, birds, mammals, and humans, all identical, like those 42 species. That means throughout 600 million years, the chemistry of the photoreceptor has been identical. For 600 million years. That, to me, is the most compelling evidence for the absolute essentiality of docosahexaenoic acid for the visual system, and of course it's involved doing the same thing in synapses, enabling you to think and do things like that. So let's look a bit about human evolution. It could not have happened without this sort of stuff, and therefore it had to be coastal. How do we get from chimpanzee to us? Chimpanzee's only got 300 grams of brain. We're only 1.5% different in terms of our genomes. It had to be that we were actually evolving beside the sea. Now, the conventional wisdom is that we learned to stand up by hunting animals and throwing spears at them. But the reality is, you take a photograph like this, you don't stand up and flash your camera at them. What you do is you crawl on the ground like the carnivores do, and you get close to them, and then you can take a picture. And standing up is just a real it's non-scientific anyway. So, and if you look at these animals in the savannas and things like that, they have no DHA. That's the 22 carbon with 6. If you look at the ratio of brain to body weight, as body weight increases, remember protein in the rhinoceros, it just falls off logarithmically like that. Now, if you look at the inside of the rhinoceros' head, that's where the brain is. That's all the brain that's inside this animal, which achieves a 1 ton body weight in 4 years. With all the protein it needs, it doesn't get the fats to make a brain. And as the animals in the land evolved to bigger and bigger bodies, their brains in relation to the body size shrank, without exception. Shove dolphins into the picture and you get a different picture. Put humans into the picture, and you can see the humans are, we don't really have a big brain. We've got a very similar body weight brain ratio to small animals like the Cebus monkey or the squirrel, for that matter. But the dolphin's a giveaway, because the marine mammals, of course, don't follow this logarithmic collapse. And of course, it's getting plenty of DHA. It doesn't get enough of the land food stuff, but there you are. Now, I had the great pleasure to visit Pinnacle Point, where Curtis Marians has got incontrovertible evidence from the first humans that walked on this planet that we have evidence of incontrovertible evidence of the absolute exploitation of the marine food web. This is South Africa, paper published in Nature, and he's extended it to quite considerable stuff. Herto in Ethiopia, the Herto, the people that lived in Herto, they were living beside the sea at the time they were living. They have a brain capacity of about 1,450 cc's. Heidelbergensis, on the other hand, miles from the sea, you've got this shallow skull with no frontal cortex, which is what makes us really different from the Neanderthals and people like that, and chimpanzees. And of course, Chris Stringer has it that we populated the planet by wandering around the coastline. Mitochondrial DNA evidence makes very clear that the only route taken was through the Pleistocene settlement of Eurasia by the ancestors of modern humans was around the coastline. This is mitochondrial evidence, and there's data on the world main estuaries, mangroves and salt marshes, and the distribution of early complex societies, which are all coastal. We went inland as populations throughout the planet exploded, but to begin with, it was all coastal. Now, of course, a lot of the conventional people don't believe this stuff, and they're very acid about it. David Attenborough hosted a conference a few years ago about it, and we really presented the evidence, but he presented a radio program on the scars of evolution in 2004, and in this program he said, I had this thought that human babies are born with vernix. Vernix is a sort of waxy, fatty substance that covers the skin. And he said, that sounds like somebody being born in water. He said, but I find no evidence of any other land-based mammal born with vernix. Would marine mammals be born with vernix? Would they? And just before the program was about to go out, he got a telephone call from a professor in British Columbia who said, I heard you're interested. Yes, the harbour seal is, definitely. So I got a friend of mine, Tom Brenner, to actually analyse the vernix from 3 different marine species to see if it was totally different to human vernix. And basically, it's the same. I think this is really compelling evidence of the fact that at some time in our early past history, we were actually living beside the sea. A little bit like the Moken today in the Far East, who live around the coastline, where the babies are born in the water, and they feed themselves by diving down and feeding themselves from the ocean floor. And they learn to walk at about 4 years of age. Now, all babies are born knowing how to swim. All babies are born knowing how to swim. We have to learn to walk on land. So I think it is very compelling that the evidence that they could not have evolved on the savannas as popularly thought. We had to be evolving a coastal resource to get access to brain food. And Philip Tobias, who was the greatest living paleoanthropologist around about the year 2000, had a conference in South Africa. And we heard all this evidence. He said this, we are profoundly and unutterably wrong. We were profoundly and unutterably wrong. Now, it takes a great man at the end of his career, having supported the hypothesis, to say, put words like that and things. Now, just a point about this. You'll see DHA with its double bonds, the little equal signs, if you like, has 6 of them. The 2 molecules that don't have 6, they've got 5. Neither of those, that's just one double bond difference, and neither of those 2 molecules were used for photoreception or synaptic signaling throughout the 600 million years. That just shows you how critical that last double bond is. And we know the quantum mechanics of it, and I could tell you all about that in another story, but we know why that 6th double bond is absolutely acutely responsible for the ability of DHA to act as an electrical signaling system like a semiconductor. But we don't have time to go into that. Just want to mention some of the work that we've been doing at Chelsea and Westminster Hospital at Imperial. And what we've studied 300 pregnancies, and we looked at the chemistry of the red cells at the recruitment and end. And what we found was that the chemistry of the red cells actually predicted preterm delivery with a better than 90% confidence. Now, it was oleic acid that did the prediction, and oleic acid is a marker for deficiency of these long-chain fatty acids like DHA. And what this means, because the red cell has a half-life of 120 days, and we're doing this analysis at 12 weeks, what this means is if you've got a 90% confidence for that, it means that the condition of the mother in the months prior to conception is actually more determinant than anything that happens during the pregnancy. Now, having said that, despite we actually supplemented the mothers with DHA and used magnetic resonance imaging to see if we could see any differences in the brains of the newborn babies. And out of 85 MRIs, we actually got some very interesting data in that we saw cortical volumes, the whole grey volume, the corpus callosum, whole brain without seeing, which is effectively the subarachnoid spaces, that these correlated with the higher, better built from the MRI evidence in the boys, but not the girls. That's interesting because boys are far more susceptible to the deficiencies of essential fatty acids. In fact, we didn't see it in the girls. It's probably twofold. One is that we only started the supplement at 12 weeks, by which time neurogenesis is pretty well finished. And the second thing is that we really want to learn from this study, if we really want to make a difference, we've got to start before conception. So that's what we've learned at Imperial. And the MRIs are coming up with all sorts of nasty things that we're seeing brain disorders in children at birth, which apparently normal children. And I think that we're going to have to change the way we look at children at birth, because we are seeing some, for example, the white matter altered signal intensity is seen at birth is the same as you see in a child with ADHD at 10 years of age. So these these disorders of the brain are almost certainly prenatal and possibly even preconception. Special educational needs, well, that roars up as birth weight falls, which goes along with prematurity. Special educational needs for the children, as do practically every disorder in the son. Cerebral palsy at normal birth weights, about 1 or 2 per 1,000 live births. When you go down to below 1,500 and preterm, probably below 28 weeks, then you have cerebral palsy 1 in 5. And that's the tip of an iceberg of a whole bunch of developmental disorders of the brain. They're born before the brain's finished developing. Fish consumption, major depression, quotes with countries. The RSPEC study is perhaps one of the most interesting ones. 14,000 pregnancies. The children were followed up after birth. And at 8 years of age, psychological analysis of the children showed that the amount of fish and seafood that the mother ate during pregnancy was directly related to psychological assessments of cognition. And you've probably heard about the cries from the FDA about mercury, how terrible that is in fish, and therefore you shouldn't be eating much fish. Well, Joe Hibbon from the National Institute of Health analysed his data of these 14,000 pregnancies, and he put it in a way that says, let's see what happens if the mother adheres to this recommendation of only 2 fish meals a week or something like that. And in fact, with 2 fish meals or less, you get the worst psychological outcomes in the child. That applies in here. You see adverse verbal IQ, adverse fine motor function, prosocial score, and social development. You exceed it, and you get the best performance. The FDA didn't bother about the benefits of fish and seafood. They just looked at mercury as a toxic substance. Now we're going to get into the crux of the matter. Global crisis in nutrition took 123 years from 1804 to add 1 billion. In 2000, it took 11 years to add 1 billion. We're looking at a logarithmic rise in the population. Now, how are we going to feed them? This is FAO's data. They've got more data now, but the wild fish catch plateaued about 20 years ago. We're not going to get any more wild fish. This is capturing fish. However, aquaculture has expanded and filled the gap to some extent. But let me put this to you, that aquaculture that means feeding fish to fish can't really go much further because the fish catch has plateaued. They're now using chicken feathers and chicken meat chicken offal rather, to feed the salmon in Norway and Scotland. Now let's look at what happened in the past. In Maryland, the oyster catch in 1889 was 616,000 metric tons. In 2002, it was only 12,000 metric tons. Apart from the loss of health-giving food, we're also losing CO2 sequestration, because in 1889, if you work out how much CO2 is embedded in the oyster shell, it is 270,000 metric tons in 1 year from this Maryland business. In 2002, it's only 7,000 tons. That means that 263,000 metric tons of CO2 are still in the atmosphere as a consequence of that. And so yeah, there you are. They're now actually actively restoring their oyster beds in this is why I'm so enthusiastic about what goes on here, because we're talking about oysters not only providing brain food, we're talking about them being a challenge to global warming, at least certainly the CO2 thing. Now, when I was young, my father always took us down to Cramondin to celebrate whatever. He found lots of excuses for celebrating. But Cramondin was renowned for its seafood, because the proprietor would go down to the foreshore on the 1st of 4th, and he would gather the fish and seafood, not fish, but the seafood, the crabs and oysters and stuff, and have them in his restaurant fresh for the evening. In 1965, I came back from Africa and said to my family, who was still living in Edinburgh at the time, let's go and have a trip down memory lane to the Cramondin. We parked the car, and then we walked down to the foreshore to have a look at this wonderful iron bridge. And we saw this notice: warning, health danger, shellfish should not be collected from the foreshores, they may be contaminated. The vets are actually telling people to keep their dogs on a leash because of the toxicity of the shellfish. They have killed that rich estuary in my lifetime. And this is not the only one that's been killed. Now here, off the Pentland Firth, the sea was 1/3 water, 2/3 fish. The operation of taking them could hardly be called fishing, for they did little more than dip for them in the water and take them up. Daniel Defoe, Tour through the whole island of Great Britain, of a visit to Scotland in 1705. There you are. This is what's happening. Practically every oyster, every estuary throughout the planet has been killed. If we were able to restore those estuaries with the sort of capability that Chesapeake Bay had a couple of centuries ago at its maximum, you need 840 of them would kill all the CO2 that humans are producing in a year. Now, I say that reservedly because actually the calculation doesn't take into account the amount of CO2 that the oysters produce during their life. But the oyster shell, once it's laid back in the water, is a haven for all the microflora and fauna that grows on it, and that is also a powerful CO2 sequestering business. So it lives, once it's dead, its life continues to support CO2 uptake. So the logarithmic license has led to Foresight think tank in 2011 to claim that there's not enough arable land, and Professor Morey mentioned it in his good introduction this morning, not enough arable land, and the future lies, they said, in further intensification of land-based agriculture. They did not talk about the sea. An incredible omission. And what we suggested to the Ministry of Agriculture and Fisheries in 1990, when they invited me to Japan to discuss the problem of the changing population and all the needs, what we said is you've got to agriculturalize the oceans. It's the only solution to save humanity. It's the only sustainable solution. And here we have, in Japan, Takahiro Tanaka, as Director of Fishery Division of the Agriculture and Forestry of Okayama Prefecture. And he's now got this wonderful place between two islands where he is doing exactly that. He has agriculturalized the place between two islands. And it got artificial reefs, a whole shooting match of stuff. These are implementing several types of artificial reefs dedicated for the different species that he's developing as product in the place. And you know all about how we use green pasture for animals, and he does the same with the sea. He has green pastures in the sea. And they're working with local fishery people. You know, it brings employment to these people, and these have been working with the communities to revitalize the eelgrass habitat. So it's all possible. And there in Indonesia, they took the message about growing kelp, and those are the kelp farms off the island of Bali, and each farm, each little square is owned by one or other persons living in the little village there. And the farmers that are farming kelp, which is also fixing CO2, the farmers that are farming are making more money than the inland farmers. And this is what has helped progress kelp farming in Indonesia, and it's solving the iodine problem at the same time and providing DHA as well. Now, the brain evolved in the sea 500 million years ago using DHA, and it also, remind you, used iodine and other trace elements like zinc, copper, manganese, and selenium in particular. And the primary food source is the marine environment. Now, when we realized this way back in 1972, we wrote a book, What We Eat Today. And in that book, we said, you know, unless you start prioritizing the brain in terms of nutrition, then you're going to get a wave of brain disorders following in the wake of the rise in heart disease. And the book was reviewed by Graham Rose in the Sunday Times, and he wrote this: unless something is done to prioritize brain nutrition, then we'll become a race of morons. Now, that's not my words, but that's what he said. And you can look it up in the Sunday Times yourself. Now, this is what's happened. The European Union assessed the health in 2004, and brain disorders came out at 386 billion, top of the bill. Everybody said this is rubbish, it's all due to modern diagnostics and things like that. So they repeated it in 2010, and it was 789 billion. We got the British government to do the same thing, and in 2007, they came up with 77 billion as the cost of mental ill health in the UK. Again, they had the same problem. Oh, it's all due to modern diagnostics. It's not a real thing at all. So they repeated it in 2010, and it was 105 billion. And the population of the UK had not shifted that much during that time. The Wellcome Trust, one of the biggest medical research charities, then had it reassessed in 2013 using the same methodology, and it came out at 113 billion. This is the greatest threat to humanity. We lose our brains, we lose everything. So last century, average height increased by 0.4 of an inch every decade at the beginning. This was the impact of the environment changing our shape. It changed our disease pattern as well, and it's changing it now in terms of mental health in a very serious way. And the options for this century are an increase in neurological disorders, a decline in intelligence, an increase in antisocial behavior, and we're seeing an awful lot of that at the moment. I don't need to remind you of some of the terrible things that are happening. The alternative, if we get it right, and it depends on you people with your oysters and all the rest of the sea productivity, etc., is that we could look forward to a time of increased intelligence, increased health, and increased peace. That's the option. And it is difficult to overemphasize the gravity of the situation. In summary, the brain evolved in the sea using DHA for its signaling systems of 500 to 600 million years ago. Humans could not have evolved, Homo sapiens could not have evolved on the savannas of Africa, where there was little DHA and all brains shrank as body size increased. In recent time, we've become increasingly dependent on intensively based, land-based foods. The rise in mental ill health and brain disorders is the greatest threat to the sustainability of humanity. And the future of our children and their children, ladies and gentlemen, is what is at stake and is in our and your hands. Thank you very much for listening.